Good morning, dear students. Today we are here with the third session of the chapter of Polynomials for class 10. The topic for today is Division Algorithm for Polynomials. You all know that a cubic polynomial has at most 3 zeros. However, if you are given only one zero, can you find out the other two? Yes, my dear children, we have a method to find out the two zeros of the polynomial if one of the zeros is given to us. For example, let us consider the cubic polynomial x cube minus 3x square minus x plus 3. If one of its 0 is 1, then by factor theorem you all know that x minus 1 is a factor of x cube minus 3x square minus x plus 3. So to find out the other two factors, we divide x cube minus 3x square minus x plus 3 by x minus 1. Let us see what we get after division. X cube minus 3x square minus x plus 3 is equal to x minus 1 into x square minus 2x minus 3. One minus 1 and 3. Let us take up an example. Divide 2x square plus 3x plus 1 by x plus 2. We have done it in class 9. Let's just revise the work. Now to divide this 2x square plus 3x plus 1 by x plus 2, what is the method? We take 2x square plus 3x plus 1, it is the dividend, and x plus 2 is the divisor. So to divide it, we take the first term of the dividend, which is 2x square, and we see the first term of the divisor, which is x. We multiply this x with 2x to get the first term of the dividend, which is 2x square. So we get on division 2x square plus 2 plus 4x. On subtraction, we get minus x plus 1. Now again, we will multiply this x plus 2 by minus 1 to get minus x minus 2. On subtraction, we get the remainder as 3. So here, we stop the division process when either the remainder comes out to be 0 or its degree is less than the degree of the divisor. So here the quotient is 2x minus 1 and the remainder is 3. If you try to multiply the quotient and the divisor and add the remainder to it, you get the dividend again. So here if I multiply 2x minus 1 by x plus 2 and add 3 to it, I will be getting the result as 2x square plus 3x plus 1, which is the dividend. Thus, dividend can be written as the divisor into the quotient plus the remainder. Now let us extend this process to divide a polynomial by a quadratic polynomial. Again, the method becomes same. I need to divide 3x cube plus x square plus 2x plus 5 by 1 plus 2x plus x square. Now, just try to recall, we first arrange the terms of the dividend and the divisor in the decreasing order of the degrees. Recall that arranging the terms in this order is called the writing of the polynomial in the standard form. I hope you all remember that. So, in this example, as the dividend is 3x cube plus x square plus 2x plus 5. So, this is already in the standard form, but the divisor is not in the standard form. So to put it in the standard form, we'll be rewriting it as x square plus 2x plus 1. Now we'll divide 3x cube plus x square plus 2x plus 5 by x square plus 2x plus 1. Carefully see, this 3x cube plus x square plus 2x plus 5 is called the dividend, and this x square plus 2x plus 1 will be called the divisor. I hope these two terms are clear, the divisor and the dividend. Now, so we'll be dividing the dividend by the divisor to get the quotient and the remainder. These four terms are very, very important for you. So what is the process? First, to obtain the first term of the quotient, divide the highest degree term of the dividend, that is 3x cube, by the highest degree term of the divisor, that is x square. This is 3x. Then carry out the division process. What remains is minus 5x square minus x plus 5. Let us see. So if we divide 3x cube plus x square plus 2x plus 5 by x square plus 2x plus 1, we get the first term of the quotient I have got equal to 3x. Now we obtain the second term of the quotient. Divide the highest degree term of the new dividend. New dividend was what? 5 minus 5x square plus x plus 5 by the highest degree term of the divisor, that is x square, and we get minus 5. So again carry out the division process. So I just take minus 5 term, I multiply with x square plus 2x plus 1, and what do I get? I'll be getting the next term as minus 5x square minus 10x plus minus 5. If I subtract it, I get 9x plus 10. So I'll just show you the division. We have got the quotient as 3x minus 5 and the remainder as 9x plus 10. Now here if you carefully see, what remains is 9x plus 10. Now what is the degree of 9x plus 10? It is 1, and this degree is less than the degree of the divisor, which was x square plus 2x plus 1. So we cannot continue the division any further and we'll stop here. So we have got the quotient as 3x minus 5 and the remainder is 9x plus 10. So to check our division, we will multiply the divisor with the quotient and add the remainder to it, and then we'll see what we get. So x square plus 2x plus 1 multiplied by 3x minus 5. You add 9x plus 10 to it and your final answer comes out to be 3x cube plus x square plus 2x plus 5, which is equal to the dividend. Thus we get dividend is equal to divisor into quotient plus the remainder. Now this is called the division algorithm for the polynomials. That is, if px and gx are any two polynomials with gx not equal to 0, then we can find polynomials qx and rx such that px is equal to gx into qx plus rx, where rx is equal to 0 or degree of rx is less than the degree of gx. So this condition of rx has to be kept in mind, that the remainder has to be 0 or the degree of the remainder should be less than the degree of the divisor. Once we get that, we can stop the division. So this result, that the divisor into the quotient plus the remainder is equal to the dividend, is called the division algorithm of the polynomials. To watch this, again you can watch the video on the division algorithm of the polynomials. I am sharing the link below. That becomes easier for you to understand then. So here is the link of the video which you can watch. So continuing with the division algorithm for polynomials, we'll be doing example 8 of your textbooks. We'll be dividing 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. So the solution is that first step should be to check whether the given polynomials are in the standard form or not. So we will convert them. If you see the dividend, 3x square minus x cube minus 3x plus 5, it is not in the standard form, so we will rewrite it as minus x cube plus 3x square minus 3x plus 5. Similarly, the divisor was x minus 1 minus x square. It is not in the standard form, so we will rewrite it as minus x square plus x minus 1. Now our dividend and divisor both are in the standard form and we can divide. On dividing, we get the quotient as x minus 2 and the remainder as 3. So now if you see the remainder, its degree is less than the degree of the divisor. Degree of the divisor was 2. Degree of the remainder here is 0. So we can stop the division here. We'll check the division. By the division algorithm, we find the divisor into the quotient plus the remainder comes out to be equal to the dividend, because after multiplying minus x square plus x minus 1 by x minus 2, we have, and adding 3 to it, we get the answer as minus x cube plus 3x square minus 3x plus 5, which is the dividend. So hence the division algorithm is verified. So now example 9 is one of the very important examples. If they have come number of times in the exams, generally you get one question of this type in the exams. So please ensure that you all understand this question properly. Now what is given to us? Find all the zeros of 2x raised to the power of 4 minus 3x cube minus 3x square plus 6x minus 2 if you know the two of the zeros are root 2 and minus root 2. If we have that zeros are root 2 and minus root 2, then x minus root 2 and x plus root 2 will be the factors. Therefore, the product of these factors will also be a factor of px. See, if 2 and 3 are the factors of some number, will 6 also be a factor of px or not? So, x square minus 2 is a factor of this polynomial. So, we divide the given polynomial by x square minus 2 and we get the quotient as 2x square minus 3x plus 1. And the remainder will definitely come out to be 0 because x square minus 2 is a factor. So, naturally the remainder has to come out to be 0. So, 2x raised to the power of 4 minus 3x cube minus 3x square plus 6x minus 2 can be rewritten as x square minus 2 multiplied by 2x square minus 3x plus 1. Now we can factorize this by splitting of the middle term and I get that 2x square minus 3x plus 1 can be factored as 2x minus 1 into x minus 1. So the other zeros are given by, so the zeros of the second polynomial 2x square minus 3x plus 1 will be given by 1 upon 2 and 1. So all the zeros of the polynomial px are root 2 minus root 2, 1 by 2 and 1. So you will be doing up the questions of exercise 2.3. That will be your homework. All the questions of exercise 2.3 are to be done. We've taken up few questions. Let us take up the few questions. The first question, divide the polynomial px by the polynomial gx and find the quotient and the remainder in each of the following. I think you all should be able to do. I have given you enough examples of the division. So you can divide and find out the quotient and the remainder. The second question, check whether the first polynomial is a factor of the second polynomial. So, you will divide the second polynomial by the first polynomial and see what is the answer coming out to be as the remainder. If the remainder is coming out to be 0, that means it's a factor of px. If the remainder is not equal to 0, that means it is not a factor of px. See, the third question is again a very important one, quite similar to that question what we had done, that if root 2 and minus root 2 are the zeros. So same way, if root 5 upon 3 and minus root 5 upon 3 are the zeros, then for sure x minus root 5 upon 3 and x plus root 5 upon 3 will be the factors of px. If they are the factors of px, then their product will also be the factor of px. So x minus root 5 upon 3 into x plus root 5 upon 3, that will be a factor of px. So x square minus 5 by 3 is a factor of px. We divide the whole polynomial by the polynomial x square minus 5 by 3 and we get the quotient as 3x square plus 6x plus 3 and the remainder is coming out to be 0. So this polynomial, this fourth degree polynomial can be rewritten as x square minus 5 by 3 multiplied by 3x square plus 6x plus 3. Now I can factorize this polynomial and I will get all the four zeros of this polynomial as what? My root 5 by 3 minus root 5 by 3 minus 1 and minus 1. Let us take up the question 4 of this exercise. I am dividing x cube minus 3x square plus x plus 2 by the polynomial gx. The quotient and the remainder were given to you as x minus 2 and minus 2x plus 4 respectively. Find gx. So here we will be using the division algorithm and then we will be finding the polynomial gx. So what is given to us? The divisor is given, the quotient is given, the remainder is given, and the dividend is given. The divisor, that is gx, is to be found out. So we'll use the division algorithm and put the values in this. Dividend is equal to divisor into quotient plus the remainder. When we do that, the value of the divisor is coming out to be as dividend minus the remainder divided by the quotient, and that will be the value of gx. So we get the value of gx by dividing x cube minus 3x square plus 3x minus 2 by x minus 2, and we get gx equal to x square minus x plus 1. Right? Let us take up the fifth question now. Give examples of the polynomials px, gx, qx and rx which satisfy the division algorithm, and the first part we'll be doing degree of px is equal to degree of qx. The solution, let us try to solve this. Now, according to Euclid's division lemma, we know that whenever a polynomial is divided by another polynomial, then this px is equal to gx into qx plus rx, where qx is not equal to 0 and degree of rx is equal to 0, or degree of rx is less than the degree of gx. So degree of px is equal to degree of qx. That is what we need. That means degree of the dividend and the quotient can be equal. In fact, here they have to be equal. This is the case only and only if the divisor is a constant term. That means its degree is 0. So we can take px to be as 3x cube minus 6x plus 5 and gx as the divisor as 3. So when you will divide, the quotient will come out to be what? X square minus 2x plus 1, and the remainder will come out to be 2. Similarly, let us take up the second case. The degree of qx is equal to degree of rx. The degree of the quotient and the remainder has to be same. So again, we will be taking up the polynomial such that the degree of the polynomial and degree of the divisor are same. The degree of qx is equal to degree of rx. So if I take the polynomial as 2x square minus 4x plus 3 and the divisor is also a quadratic polynomial, then the quotient will be a constant term and remainder will also be a constant term, such that I will be getting the degree of the quotient and the remainder will come out to be same. So third question, you can try it out on your own. This optional exercise, again, these two questions that we'll be taking up, they are very important of exercise 2.4. If two zeros of the polynomial x is to the power of 4 minus 6x cube minus 26x square plus 138x minus 35 are 2 plus root 3 and 2 minus root 3. Find the other zeros. This 2 plus minus root 3 means 2 plus root 3 is 1 0 and 2 minus root 3 is the other 0. So what we have done here is, since 2 plus root 3 and 2 minus root 3 are the zeros, then x minus 2 plus root 3 and x minus 2 minus root 3 will be the factors of this polynomial. That means x minus 2 minus root 3 and x minus 2 plus root 3 will be the factors of px. Therefore, their product will also be a factor. That means x minus 2 whole square minus root 3 whole square will also be a factor of px. That means x square minus 4x plus 1 is a factor. So once we found out one factor, what we do is we simply divide the polynomial by this factor. The quotient that we get, that can be factored to get the other factors of this polynomial px, and whatever other factors, from that we can find out the zeros of the required polynomial. So after dividing the polynomial x is to the power of 4 minus 6x cube minus 26x square plus 138x by minus 35 by x square minus 4x plus 1, we get the quotient as x square minus 2x minus 35 and the remainder comes out to be 0. So therefore the px, the polynomial px, can be written as x is to the power of 4 minus 6x cube minus 26x square plus 138x minus 35. It can be rewritten as x square minus 4x plus 1 multiplied by x square minus 2x minus 35. Now this second quadratic polynomial x square minus 2x minus 35 can be factorized by splitting of the middle term into x plus 5 into x minus 7. So px can be factored as x square minus 4x plus 1 into x plus 5 into x minus 7. Thus, The other zeros we can find out by putting x plus 5 equal to 0 and x minus 7 equal to 0, and we get them to be as x is equal to minus 5 and x is equal to 7. Thus the other zeros are x is equal to minus 5 and x is equal to 7. Let us take up question 5 now. If the polynomial x raised to the power of 4 minus 6x cube plus 16x square minus 25x plus 10 is divided by another polynomial x square minus 2x plus k, the remainder comes out to be x plus a. Find k and a. Let us try to solve it. We have the divisor given to us, dividend and the remainder. By the division algorithm of the polynomials, we know that the dividend is equal to divisor into quotient plus the remainder. So if I subtract the remainder from the dividend, I will be left with divisor and the quotient only. That means on dividing that difference by the divisor, whatever remainder I will be getting, that remainder will come out to be 0. So on subtracting the remainder from the dividend, what do I get? I get x raised to the power of 4 minus 6x cube plus 16x square minus 26x plus 10 minus a. When I divide it by x square minus 2x plus k, whatever remainder I will be getting, that will be equal to 0. So let us divide and check. After division, the remainder that I have got, that remainder is minus 10 plus 2k into x. I have got minus 10 plus 2k into x plus 10 minus a minus 8k plus k square. Now I will equate them to 0. So minus 10 plus 2k is equal to 0 gives me k is equal to 5. And when I get this k is equal to 5, I will be getting, putting this k is equal to 5, I get the value of a equal to minus 5 by putting 10 minus a minus 8k plus k square equal to 0. So hence k comes out to be 5 and a comes out to be minus 5. Now to recap the whole thing, you can watch this video link. I have shared the link with you. In case you have any problem, the complete PPT will be shared with you on Drive. Plus I will be also sending the video with the voice so that you can understand it better. So thank you children. Have a safe and a happy day.